So objective number 3 then, we're going to have to use our other converter, be able to convert between moles and grams or grams and moles. So now 1 mole is equal to X grams because each element has its own unique mass depending on how many protons and neutrons are in it. So how many moles of sodium chloride are in a 454 gram sample? So first thing I need to know is what's the formula for sodium chloride? Well, sodium's a metal with a +1 oxidation number. Chlorine's a nonmetal with -1. So we're just talking NaCl here. So that means 1 sodium at 22.999 or 23 grams plus 1 chlorine at 35.45. So I've got a molar mass of 58.45. So I'm still going to write down the number I was given in the problem first, 454 grams, and then I'm going to set up my converter, and I want moles, so I put it on top. I have grams, so it's 1 mole is 58.45 grams. And at this point, you should be looking and saying, okay, well, that's more than 1 mole. It's not quite 10 moles, but it's a few. So 454 divided by the 58.45 gives me 7.77 moles of NaCl. The second question says how many grams of dinitrogen pentaoxide are in 5.45 moles. Well, this time I recognize that these prefixes are telling me my formula is N2O5 because this is a covalent substance. So I'm going to have 2 nitrogen at 14.01 plus the 5 oxygen at 16. So 5 times 16 plus nitrogen, 108.02 is how much that weighs. But again, my beginning step is to write down this 5.45 moles and then set up my converter. And my converter needs grams on top this time and moles on the bottom. So it's 108.02 grams over 1 mole. And since this is 5 moles, I'm going to be looking at over 500 grams here. 588.7 grams. How do you know how many decimals to keep? Well, kind of the general rule is you look at how many digits your measurements had. And since I had 4 digits, that's what I keep in my final answer is 4 digits. Or I could have even gone to 3 since the 5.45 moles only had 3 digits. But we're not going to worry too much about the sig figs.